Hello, hi everyone. Hope that everyone are fine and doing well. In my previous classes, we have discussed about various network fundamental concepts related to CCNA. Today's session is on physical layer. So before going to what is physical layer, so physical layer is one of the layers in OSI or OSI reference model, which explains about how physical layer protocol services intermedia support communication across data network. Apart from this, physical layer also involved with number of router, number of switches, number of PCs connected in each network. Now I'm going to share a screenshot. Slides. I'm going to share now. So physical layer. As I said, physical layer explains how physical layer protocol services network media supports communication across or over the data network. So what are the topics and topic objectives we are going to cover in this session? First one is purpose of physical layer. Topic objective is describe the purpose and functions of the physical layer in the network. Physical layer characteristics, describe characteristics of physical layer. Copper cabling, identify the basic characteristics of copper cabling. UTP cabling, explain how UTP cable is used in Ethernet networks. Fiber optic cabling, describe the fiber optic cabling and its main advantages over the media. Wireless media, connect devices using wired and wireless media. Purpose of the physical layer. So what is the basic purpose of physical layer? Before any network communication can occur, a physical layer to a local network must be established. So before communication established, the responsibility of the physical layer is to connect to the local network first. This connection could be wired or wireless, depending on the setup of the network. This generally applies whether you are considering a corporate office or home. Next point is a network interface card, NIC. Connects a device to the network. Some devices may have just one NIC, while others may have multiple NICs, wired and wireless. For example, not all physical connections offer the same level of performance, as different PCs has different, you can say, of different types of speeds, different types of processors. Depending on the processor, speed varies. So physical layer. The purpose of physical layer. What is the purpose of physical layer? Transports bit across the network media, access a complete frame from the data link layer, and encodes it as a series of signals that are transmitted to the local media. This is the last step in the encapsulation process. The next device in the path to destination receives the bits and recapsulate the frame, then decide what to do with it. So this is a scenario when a web client is connected to the web server and web client is requesting web server to upload the data packets, and while data packet move from web client to web server or web server to web client, it does not point a single bit as the data packet. With data packet, some other bits also associated with each: user data, TCP segment, IP packet, Ethernet frame. These are the different data packet, data frame format attached with it. Physical layer characteristics is the most important thing in this session. So, as I said, in OSI reference method, there are 7 layers: application, presentation, session, transport, network, data link, physical. These first 6 layers, the TCP/IP standards are implemented in software and governed by the IETF, while the data link and the physical last 2 layers, the physical layer standards are implemented in hardware and are governed by many organizations including ISO, EIA or TIA, ITU-T, ANSI, IEEE. Already we have discussed about these organizations in the previous session. Physical layer characteristics, physical components. Physical layer standards address the 3 functional areas. These are physical components, encoding, signaling. The physical components are the hardware devices, media, and other connectors that transmit the signals that are represent the bits. Hardware components like NIC, interface, and connectors, cable materials, and cable designs, and are specified in standard associated with the physical layer. Physical layer characteristics continuing. Encoding. So encoding is the process through which data is converted the stream of bits into format recognizable by the next device in the network path. The coding provides predictable patterns that can be recognized by the next device. Example of encoding method include Manchester, as shown in this figure. Just refer this figure. This is 0, up means 1, again down means 0, again down means 0, again up means 1, this is down 0, this is up 1, this is down 0, like that it continues. This is one of the encoding process, how data packets moves from one device to another device through encoding process. Physical layer characteristics, signaling. The signaling method is how the bit values 1 and 0 are represented on the physical medium. The method of signaling will vary based on the type of medium being used. Light pulse and time. So microwave signal over wireless. So this is voltage. This side is time. Digital signal, AM, amplitude modulation, frequency modulation, pulse modulation. These are the different modulation techniques which it is showing. Physical layer characteristics, bandwidth. The bandwidth is the capacity at which medium can carry data. Digital bandwidth measures the amount of data that can flow from one place to another in a given amount of time. How many bits can be transmitted in a second? Physical media properties, current technologies, and the laws of the physics play a role in determining available bandwidth. Bits per second, BPS. 1 BPS equal to 100 unit of bandwidth. Kilobits per second, kbps. 1 kbps equal to 1000 bps equal to 10 power 3 bps. Megabits per second, mbps. 1 mbps equals to 1 6 times 0 bps, like that. Gigabits per second, gbps. 1 gbps equals to 1 10 times 9, sorry, 9 times 0 bps. Terabits per second, tbps. 1 tbps equals to 1 12 times 0 bps. This is the bandwidth how bandwidth are measured. Units. Bandwidth terminology, different bandwidth terminology are there, like latency, throughput, output, etc. Latency is the amount of time, including delays, for data to travel from one given point to another point. While transmitting the data packet from one node to another node, it is the time of delay is called latency. Throughput, the measure of transfer of bits across the media over a given period of time. Output, the measure of usable data transferred over a given period of time. Output equal to throughput minus traffic overhead. The formula to calculate output, throughput minus traffic overhead. Copper cabling. So there are different types of copper cablings are there in networking. Characteristics of copper cabling. Copper cabling is the most common type of cabling used in networks today. It is inexpensive, easy to install, and has low resistance to electrical current flow. Limitation, attenuation. The longer the electrical signal have to travel, the weaker they get. That means while we send any electrical signal over a long data path, then definitely the signal attenuation or signal frequency degrades. At the output, less. At the end, we get less frequency signal. So for this reason, we need to develop such a cable which will degrade this signal characteristics very lessly. The electrical signal is susceptible to interference from two sources which can distort and corrupt the data signals: electric interference EMI, radio frequency interference RFI, and crosstalk. So while transferring the signal from one end to another end, there may be electric interference may happen, or radio frequency interference may happen, or crosstalk may happen, or due to thunder or external parameters, the signal loss may happen. So this should be overcome by the cable. Mitigation: strict adherence to cable length limits will mitigate attenuation. Some kinds of copper cable mitigation EMI and RFI by using metallic shielding and grounding. Some kind of copper cable mitigation crosstalk by twisting of opposing circuit pair wires together. Types of copper cabling. These are the three types of copper cabling. One is on-shielded twisted pair cable, UTP, and then next one the shielded twisted pair cable, STP. Last one the coaxial cable. So these are three types of copper cables available nowadays: UTP, on-shielded twisted pair; STP, shielded twisted pair; coaxial cable. First one is UTP, on-shielded twisted pair cables. So as you see, there are four colors in UTP in wires. So UTP is the most common networking media, terminated with RJ45 connectors, interconnects host with intermediate network devices. Key characteristics of UTP: the outer jacket protects the copper wires from physical damage. Twisted pair protect the signal from interference. Color coded plastic insulator electrical isolates the wire from each other and identify each pair. So there are four color formats in on-shielded twisted pair cabling. Shielded twisted pair, STP. This is in case of UTP, we don't have a shield, but in case of STP, we have a external protection on top of wires, that is called shield. So what are the advantage of that shield? Better noise protection than UTP, more expensive than UTP, harder to install than UTP, terminated with RJ48 connectors, interconnect host with intermediate network devices. Key characteristics of STP. What are the different characteristics of STP? The outer jacket protects the copper wires from physical damage. Threaded or foil shield provides EMI or RFI protection. Foil shield for each pair of wires provides EMI or RFI protection. Color-coded plastic insulation electrically isolates the wires from each other and identify each pair. So as you see in the figure, this is also, there are also four different color combination are there, and on top of it, on each color, each two wires with coated with a shield. Then total with total 4 plus 2 8 wires is shielded with a outer jacket. Then another outer jacket also there. So there are 3 jackets over the wires. So it is expensive than UT. Coaxial cables. So coaxial consists of following: outer cable jacket to prevent minor physical damage, a woven copper braid or metallic foil acts as a second wire in the circuit and as a shield for the inner conductor, a layer of flexible plastic insulator. A copper conductor is used to transmit the electronic signals. There are different types of conductor used with coaxial cable. Commonly used in the following situation: wireless installations, attach antennas to wireless devices, cable internet installations, customer premises wiring. So this is the figure of coaxial cable, and coaxial cable is of 3 types: BNC, N type, F type. UTP cabling. Properties of UTP cabling: unshielded twisted pair has 4 pairs of color coded copper wires twisted together and encased in a flexible plastic sheet. No shielding is used. UTP relies on following properties to limit crosstalk: cancellation. Each wire in a pair of wires uses opposite polarity. One wire is negative and the other wire is positive. They are twisted together and the magnetic fields effectively cancel each other and outside EMI or RFI. Electromagnetic inference, radio frequency inference. Variation in twisted pair foot in each wire. Each wire is twisted a different amount, which helps prevent crosstalk among the wires in the cable. Then UTP cable standards and connectors. So these are the different UTP standards and connector. Like UTP standards are standards for UTP are established by TIA or EIA. EIA 568 standard elements like cable types, cable length, connector, cable termination, testing methods. Category 3 cable UTP, category 5 and 5E cable UTP, category 6 cable UTP. Electrical standard for copper cabling are established by the IEEE, which rates cable according to its performance. Example include category 3, category 5 and 5E, category 6. So these are the UTP cabling standards and connectors. These are the connectors used, like RJ45 redundant jack 45 connector, fully terminated UTP cable, it is not properly connected. RJ45 socket, properly terminated UTP cable. This is the properly connected. It is properly connected and it will work perfectly, but this is not properly connected. straight through and crossover UTP cables. Basically, in CCNA course, we are going to use straight through cables and crossover cables. Straight through cables are used where dissimilar type of devices are there. Like dissimilar means PC and switch. These are two dissimilar type device. Because switch has no memory, whereas PC has memory. And the crossover is used in case of PC and router. These are similar types of devices, like because PC has memory and router has memory. Straight through also used in switch to router, because router has memory, buffer memory, whereas switch has no memory. So this is the how the connection is being happened here. One color combination green, 1 2 3 4 5 6 7 8, T568A and T568B. So this is the color combination, how we are going to put the colors together. Ethernet straight through, both ends T568A and or 568B, as it is shown in the above figures. Host network devices, Ethernet crossover, one end T568A and other end T568B. Host to host, switch to switch, router to router. As I said, crossover connection is used in similar devices, switch to switch, similar, host to host, PC to PC, or PC to router, similar device, or router to router. Whereas straight through is being used host to network, host to means PC to switch, or switch to router, like that. Rollover, Cisco proprietary host serial port to router or switch console port using an adapter. Fiber optic cable. Basically, fiber optic cables are very costly in nature, but transmission speed is very high in case of fiber optic cable in comparison to UTP and STP. Properties of fiber optic cabling, not as common as UTP because of the expense involved, ideal for some networking scenarios, transmits data over longer distances at higher bandwidth than any other networking media, less susceptible to attenuation and completely immune to EMI or RFI, made of flexible, extremely thin standards for a very pure glass, uses a laser or LED to encode bits as pulses of light. The fiber optic cable acts as a waveguide to transmit light between the two ends with minimal signal loss. So types of fiber media: single mode fiber, multi-mode fiber. These are the two types of fiber media. Single mode fiber, very small core, very expensive lasers, long distance applications, whereas in multi-mode fiber, larger core uses less expensive LEDs. LEDs transmit at different angles up to 10 Gbps over 550 meters. Fiber optic cabling uses. Fiber optic cabling is now being used in 4 types of industry. First is enterprise networks, fiber to home, FTTH, long haul networks, submarine cable networks. These are the 4 networks where fiber optic cabling is being used widely in industry. Fiber optic connectors, straight tip connector, S-tip connector, lucent connector, LC simplex connector, subscriber connector, SC connector, duplex multimode LC connectors. So these are the 4 fiber optic connectors. Fiber patch cords. So these are the wires: SCMM patch cord, LCSM patch cord, STLCMM patch cord, STSC SM patch cord. A yellow jacket is the single mode fiber cables and orange or aqua for multi-mode fiber cables. Fiber optic versus UTP cabling. This is the difference. Implementation issues: bandwidth supported UTP 10 Mbps to 10 Gbps or fiber optic cable 10 Mbps to 100 Gbps. Distance: UTP cabling can support up to 1 to 100 meters, whereas fiber optic cabling supports very large distance related to UTP cabling 1 to 1 lakh meters. Immunity to EMI RFI low in UTP, high in fiber optic cable. Immunity to electrical hazards low, high in fiber optic cabling. Media and connector cost lowest in case of UTP cabling, highest in fiber optic cabling. Installation skills required lowest in case of UTP cabling, highest in fiber optic cabling. Safety precautions are lowest in case of UTP cabling, whereas in case of fiber optic cabling, safety precautions are very high. Highest. Wireless media. Properties of wireless media. As we have already discussed about wired media, so that we need to go for wireless because in wired media cost is very high in comparison to wireless media. Wireless media carries electromagnetic signals representing binary digits using radio micro frequency. This provides the greater mobility option. Wireless connection numbers continue to increase. Some of the limitations of wireless: coverage area, interference, security, shared medium. These are the limitations of wireless over wired. Coverage area: effective coverage can be significantly impacted by physical characteristics of the deployment location. Interference: wireless is susceptible to interference and can be disrupted by many common devices. Security: wireless communication coverage requires no access to physical stand of media, so anyone can gain access to the transmission. Shared medium: WLANs operate in half duplex, which means only one device can send or receive at a time. Many users accessing WLAN simultaneously results in reduced bandwidth for each user. Types of wireless media: there are different types of wireless media there. So wireless standards: Wi-Fi. First one is Wi-Fi. IEEE 802.11 wireless LAN WLAN technology. Bluetooth IEEE 802.15 wireless personal area network WPAN standard. WiMAX IEEE 802.16 uses a point to multi-point technology to provide broadband wireless access. Zigbee IEEE 802.15.4 low data rate, low power consumption communication, primarily for Internet of Things applications. Wireless LAN. In general, wireless LAN requires the following devices: wireless access point AP, wireless NIC adapters. So wireless access point concentrate wireless signals from users and connect to the existing copper-based network infrastructure. Wireless NIC adapters provide wireless communications capability to network hosts. There are a number of WLAN standards. When purchasing WLAN equipment, ensure compatibility and interoperability. Network administrator must develop and apply certain security policies, stringent security policies and processes to protect WLAN from unauthorized access and damage. Packet tracer and connect to wired and wireless LAN. In packet tracer simulator software, we will find connect to cloud, connect to router, connect to remaining devices, verify connection, examine the physical topology. We can do it. So this is the end of this session. So what we saw, we have just see the physical media, physical layer. And in physical layer, what are the things we studied? We have just studied wired media and wireless media and different components associated with it. Hope that everyone has enjoyed this session. Thank you for joining this session. Thanks.